Hello statistics students, my name is Emigh, and this video starts our course. So welcome to statistics class. Before you watch this video, I need you to go to Canvas, click on Files. I need you to open the document titled Chapters 1 through 3 Notes with Blanks. Okay, go ahead and do that now. Pause the video if you need to. Once you've done that, now you can print this document. Make sure you print it 4 slides per page, double-sided, just to help you save some paper. Or if you are not going to print it, you can download it onto a device as long as you can annotate on that device in your own handwriting. Because either way, whether you're printing it or you're downloading it and annotating on it, you're going to be turning this document in. You're going to be uploading these notes to Canvas with the blanks filled in your own handwriting after each chapter, okay? In your own handwriting. That's important. I have students in the past, they try to type the whole thing in. And for a while that is good, but then when we start to work with formulas and graphs, there's stuff that you have to be able to annotate. So writing on it in your own handwriting, okay? So no notes are accepted if the blanks are just typed in. You gotta handwrite them in. All right, once you are prepared, either with your printed document or your device that you can annotate on, then you're gonna watch the videos on YouTube while filling in the blanks on that document. And you can stop as frequently as you want to try to do some of the corresponding homework in my lab in mastering. That's pretty much how the whole course is ran. You print or download the document. Then you go to my YouTube videos, you watch the video while filling in the document in your own handwriting, and then you do the homework in my lab in mastering. You'll turn in your notes, you'll take a test on it, and then you'll do it again with the next set of notes, which would be, in this case, chapters 1 through 4. All right. Before we get ahead of ourselves, though, this is the official textbook for our class. You do not have to purchase a hard copy of it. You do have to purchase access to my lab in mastering, which will include the electronic version of the textbook. My lab in mastering is also the website that you will use to do your homework, take your tests, see your grades, and it will be your calculating technology. We do not use a graphing calculator in this class. We use a spreadsheet, and the name of the spreadsheet program is called StatCrunch. It comes with your purchase of this textbook through my lab in mastering. And don't worry, I will walk you exactly how to do that step by step during orientation. All right. So it's time to start filling in those blanks. First blank, go ahead and write this in, chapter 1. Next blank, write it in, Introduction to Statistics. And in that third blank, you can write in that we are about to discuss section 1.1, Statistical and Critical Thinking. And you can pause this video at any time if you want more time to write, to fill in those blanks, because I'm probably moving a little bit faster than you would be handwriting. So good news about the videos. Pause it, rewind it, watch it as many times as you need. First slide is on definitions. We need to fill in the blanks below with the correct words from this list. Okay, each of these blanks, how many do we have? 1, 2, 3, 4, 5. They're going to be filled in with these words right here in some order. This is not the first one, and this is not the second one, this is not the third one. You got to put them in the right order. Okay, they are census, population, statistics, sample, and data. So what I want you to do right now is pause the video and try to fill them in. In which order do those 5 words go according to these definitions here? Feel free to look it up online if you want, go to your electronic textbook if you want, or at this point, just see if you can figure it out. You've heard these words before: census, population, statistics, sample, and data. So maybe just try it. All right, pause the video now. Welcome back, grade your own. If you put data for the first one, a collection of observations, such as measurements, genders, survey responses, great job. If you put population for the second one, you got it right. A set of items or events that we make inferences about. Example of a population would be, let's say, LBCC students that were born in a particular year. Next is a sample that is a sub-collection of the data values from a whole population. So example of that would be you just take a sub-collection, so some of those LBC students born in the particular year of interest. You just do a sample of them. It's called a sub-collection from the population. Fourth one, if you put census, you got it right. That's a complete collection of data values from a population. You've probably heard of the U.S. Census before. There's a big goal of collecting data from every data value in the United States of America. Last one, if you put statistics, nice job. That is the science of planning studies and experiments, obtaining data, and then organizing, summarizing, presenting, analyzing, interpreting, and then drawing conclusions based on that data. That's the class that we're in, statistics. That's what we're going to be doing. Planning studies and experiments, gathering data from that, taking that data and organizing it, summarizing it, maybe making graphs about it, and then presenting it to our audience or whoever is interested, analyzing, interpreting, and drawing conclusions based on that data so that we can make well-informed decisions about how to move forward or maybe change some things we've done in the past. Let's take a look at this example, residential carbon monoxide detectors. In the journal article, residential carbon monoxide detector fail rates in the United States. It was stated that there are 38 million carbon monoxide detectors installed in the United States, when 30 of them were randomly selected and tested, and it was found that 12 of them failed to provide an alarm in hazardous carbon monoxide conditions. Interesting. Okay, so we've got 38 million detectors. 30 of them were randomly selected and tested. 12 of those 30 failed. Our task at this point in our studies is, can we determine the population? Which one of those values, the 38 million, the 30 tested, or the 12 that failed, which one is the population? If you said the 38 million, you got it right. That's the whole population, okay? Population, all of it. All the things we're interested in. What is the sample that took place in this, from the article we're reading here? Is it the 38 million, the 30 that were randomly selected, or the 12 that failed? If you said it was the 30 detectors that were selected and tested, you got that right. So of that 38 million, 30 of them were selected and tested. Not too many, only 30 out of 38 million. It's a pretty small sample size. Regardless, 12 of them failed. The objective is to use the sample data as a basis for drawing conclusions about the population of all the carbon monoxide detectors. And methods of statistics are helpful in drawing that conclusion. So here we had 12 of our 30 fail. Type that in your calculator, just any calculator on your phone is fine. 12 divided by 30. That gives us 0.4. 0.4 is a decimal. That is the probability that one of them selected failed. Sometimes we like to move that decimal 2 places, this decimal here. By moving it 2 places this direction, we look at what's called the corresponding percentage. That would mean of our sample, 40% of them failed to provide an alarm in hazardous carbon monoxide conditions. So what we would then do, the objective here is to say, well, we don't have the resources or the time to get to all 38 million and figure out if that 40% is holds. So we are going to say that we think from the sample that the true true percentage of the whole population that will fail will be 40%. Moving on, conducting a statistical study. Take some steps. First, you have to prepare. Clearly define the mission of your study before you start. Check, is the source of the objective biased? What does that mean? An example, if an organization is receiving money, keyword right there, receiving money from a foundation, then there is incentive to produce results in line with that foundation's goal, that funder's goal, the person giving them money. That would be considered a bias. You'll then need to analyze your data. Graphs, tables, visual tools to explore large sets of data. You're going to want to use technology, common sense, and sound statistical methods through your analyzation. Next, you need to make some conclusions. Make sure you're considering what's called statistical significance. That is achieved when a result is unlikely to occur by chance. For example, 92 girls in 100 births. That would be statistically significant because it is not likely to have occurred by chance. There must have been some intervention, some experiment. Unlike 52 girls in 100 births, that would not be what's called statistically significant because that easily could have just been the results by chance. Now, it is possible for a treatment to have statistical significance, like this 92 out of 100, that has statistical significance, but not practical significance. Here's an example. Common sense, that's one way to describe what we call practical significance. Common sense might suggest that the findings do not have practical significance. For example, in a study of a weight loss program, 50 subjects lost an average of 3.8 pounds after 1 year. This result does not have practical significance. Thinking about it common sense wise, a person starting a weight loss program is likely trying to lose more than 3.8 pounds. I like to think of it as if you saw that results and you were trying to lose weight, would you pay for this product? And they're like, well, 50 of our subjects lost an average of 3.8 pounds. Are you going to go invest in that company, give them your money? If the answer is no, you might be identifying that it does not have practical significance. There are many flawed statistical methods. Let's use the same fill in the blanks below with the correct words from this list to talk about flawed statistical methods. Words are percentages, small samples, self-interest study, and question/word order. Pause the video and figure out in which order those 4 words fill in these blanks based on these definitions. Go ahead and pause the video now. Welcome back, grade your own. If you put small samples for the first one, you got it right. 3 students were surveyed and none of them had been suspended. Therefore, the school has a 0% suspension rate. That's lowercase n, sample size equals 3. Not enough. Keep talking, get a larger sample before you calculate that suspension rate. Second one, if you put percentages, you got it right. Continental Airlines states, we've improved 200% in the last 6 months with respect to lost baggage. This claim may be misleading because some percent of baggage is still lost. It's a flawed statistical method. Look out for percentages. Self-interest study. If you put that for the third one, nice job. That's a survey in which the sponsor can obtain monetary or other gains from the results. That's the biased source we were talking about. Be very wary of studies where the sponsor has certain interests to promote. Sponsors, the funder, okay? All right, fourth one, if you put question/word order, you got it right. This is an interesting example. When asked, does traffic or industry contribute more to air pollution? 45% said traffic. 27% said industry. Okay, same thing. We're going to change the order of the words. When asked, does industry or traffic contribute more to air pollution? 57% said industry, 24% said traffic. It almost completely flipped. The word that was said first got the higher percentage. If you're studying psychology, you can look into that more. What is it about the first word that we hear? Did that have some effect on our results? More flawed statistical methods. Let's go again. Pause the video and fill in these four blanks in the correct order according to the definitions. The words are precise numbers, voluntary response sample, missing data, and loaded questions. Pause the video now. Welcome back. Let's see how you did. If you put precise numbers for the first one, you got it right. Saying that the population consists of all 241,472,385 adults in the United States. If a figure is precise, it might incorrectly be assumed to be accurate. That should have been given as an approximation. Too precise of a number there. Someone might think that's the actual number. Second one, if you put missing data, great job. That's the U.S. Census we were talking about before. That suffers from missing people, and they tend to be homeless or low income. And missing that data would not give us a good representation of the entire population. Third one, if you put loaded questions, you got it right. When asked, should the president have the line item veto to eliminate waste? 97% of respondents said yes. But when asked, should the president have the line item veto or not? Only 57% said yes. This is a loaded question, the way that it's stated in the first way. Should the president have the line item veto to eliminate waste? That is a loaded question. There's one word in there that makes it a loaded question, and that is the word waste. When we hear waste, we think that's trash, right? That's got to go. We've got to do something about that. We've got to eliminate the waste. But who's to say what waste is? One person might think something is waste, and to someone else, that might be a very valuable part of their community. Notice that when they took the word waste out and asked should the president have the line item veto or not, only 57% said yes compared to 97%. That's huge. It's a loaded question. Look out for them. These are flawed statistical methods. Last one. If you put voluntary response sample, you are right. This one comes up a lot. Just driving in my car, just listening to media. I hear voluntary response samples. Scrolling through social media, I see voluntary response samples. What is it? Well, it's when a survey, let's say, is put out there and volunteers are asked. They're asked, would you be a part of this? So they could say yes or no. So only those that respond have voluntarily chosen to respond. Here's an example. Nightline asked viewers to call in about whether the United Nations headquarters should remain in the U.S. 67% of the 186,000 respondents said yes. 28% of 500 non-voluntary respondents said yes. Check out the difference. When it was when people just voluntarily called in, 67% said yes. If you just randomly select 500 non-voluntary response, we got 28% that said yes. Massive difference. This is huge. Okay? We have to look out for voluntary response samples. If you see a voluntary response sample, that 67%, like in this example here, should only be used to make a projection about those people who called in. You should never say that then, okay, that means 67% of the entire U.S. population feels that way. Don't do that. That 67% addresses something about those who volunteered to call in only. It does not represent the full population in any way. Okay, so look out for that. Next time you hear or see one, I hope you spot it as a voluntary response sample. Like this guy right here. Would you tell me how you feel about this? Clipboard says Justin Bieber. People that are going to stop and talk about Justin Bieber may have a preconceived idea of how they feel about Justin Bieber. People that don't even know Justin Bieber, that name, might just walk by, right? So that is going to definitely affect the responses gathered from this question. How do you feel about Justin Bieber? All right, we need to do a little math review. Got 4 questions for you. I want you to pause the video and try these 4 questions now. Welcome back. Let's see how you did. Number 1, if you wrote that as 0.01, excellent work. 1% as a decimal is 0.01. 2 ways that are often used to obtain that answer would be taking where the current decimal is. Well, right now it's invisible. It's implied. It's right here. Even though you can't see it, it's here, okay? I could, just to be even more visual, I could rewrite that as 1.0%. It's the same thing. I'm just writing it in a way that really highlights the location of the decimal. So if we take that decimal and we move it 2 spaces in this direction, we will obtain what is called the corresponding decimal, which would be a 0 in front of this, a 0 here. Once you do that, you got to lose that percentage sign. Okay, so 0.01. If you want to put that percentage sign back, you got to move that decimal back. Now, the second way, not just visually moving it, but actually calculating it. Moving the decimal 2 places this way is actually dividing something by 100, and moving the decimal 2 places the other direction, like we did in a previous slide, that is actually the same as multiplying something by 100. So if you want to check it out, take your if the visual part doesn't work for you, you want to go with calculation, take your calculator out, type in the 1, and to get rid of the percentage and end up with a decimal, you're going to hit divided by that symbol, like that in most of our calculators, and then you type in 100. And you will get this result here. And then to undo that, the inverse operation of division is multiplication. So while you have your calculator out, try it again. Type this in, which might still be on your screen, but then type in times 100. And that will get you back to your 1, and at that point you get to put the percentage symbol back on. All right, number 2, if you put 297.84, you got the first part right. That is a poll. 34% of 876 adults said that they have taken geometry in their lifetime. The question is, what is the exact value? 34% of that 876. So to do this part right here, to get that 297.84, we use the operation multiplication. It's invisible. You can't see it right here. In between these 2 parentheses like this are a way to represent multiplication. You can add a little dot if you want to actually see a multiplication symbol. And then notice we didn't do 34% times 876, but we did the corresponding decimal, 0.34 times 876. And that got us 297.84. Whenever you're typing numbers into your calculator like this, make sure not to use the percentage, but to use its corresponding decimal. All right, little note. That answer right here, the 297.84, that is called the exact. This is going to come up in your homework questions, so pay attention. This right here is called the exact value. 297.84, 34% of 876. Now, in your homework, it's going to say, well, what's the actual number? You got to check what's our units here. We're talking adults, okay? Adults. That would be counted in whole numbers. We call that discrete data. We would count it as 1, 2, 3, 4, 5, 6. So even though this value is the exact one, the actual number of adults would be, you got to round to the nearest integer, which is 298. That is an actual count of this type of data representing adults. Exact, actual. Look out for it. It's going to come up in the homework. Number 3, if you put 95%, excellent job, you got it right. On a test, if 40 questions are answered, 38% of them are correct. What is the percent that is correct? To find a percent, okay, check this out. What is the percent? To find a percent, you got to use division, okay? You got to take the 38% that was correct. That would be your numerator. You got to put that over the total number, 40. Try it. Type this in your calculator. 38 divided by 40, hit enter. It's going to output for you 0.95. If you stop at the 0.95, you haven't made any errors, but you haven't given the answer to the question. The question was, what is the percentage? So you got to take your 95.95, turn it into a percent, and you can do that. Let's use the visual way. Take the current decimal and move it over 2 places. So this 0.95 is equivalent to 95. And once you move that decimal, you have to put on the percent symbol. All right, number 4, rounding. If you are rusty or don't know how to round, I suggest you go online, maybe find just like an easy rounding game, something. You can also refer to this visual to help you. Here's the decimal place. This position right here is called the tens, hundredths, thousandths, 10 thousandths, and 100 thousandths. On the other side of the decimal are our whole numbers. Ones, tens, hundreds, and thousandths. Okay, so in this class, we are often asked to round. So if this is what your calculator is showing, okay, calculating technology. Let's say you get this as the answer. And so you're like, okay, I want to report my answer. You got to check. How do they want this answer? If they're asking you for the nearest 10th, okay, nearest 10th, that's the first decimal place. So you would give your answer as 0.8. How to switch to an 8? The 10th place is currently a 7. It will either stay a 7 or move up to an 8. It will never drop to a 6, okay? How do you know if you keep it as a 7 or round it to an 8? You look at the next number. 5 means round it up to an 8, because that's getting us closer to 8/10ths than it is to 7/10ths. Hundredths, 2 decimals, 0.76. Thousandths, 3 decimals, 0.755. First decimal place, rounded to 1 decimal place, rounded to 2 decimal places, rounded to 3 decimal places. Also called rounding to the nearest 10th, 100th, 1000th. All right, this one's tricky. 1/10 of a percent. Correct answer is 75.5%. Let me help you with this one, okay? This is telling us 2 commands. It wants the nearest 10th, but it also wants a percent. You need to do these in a particular order. You have this task at hand, so providing 1 decimal, and you have this task at hand, providing a percentage. Do the percent part first, okay? Percent part first, then round to 1 decimal. Rounding up, like when you cut off decimals, when you round it, that always goes at the very, 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 very end of our work. So do the percent part first. So of this right here, you would move the decimal place once, twice. So you end up with 75.54432970312. Then you round that to the nearest tenth. So that would be 75 point. This 5 will either stay a 5 or it will go up to a 6. It will never drop to a 4. The next number is what tells you if it'll stay as a 5 or increase to a 6. It is a 4, which means this number stays a 5 because we are closer to 5/10 than 6/10. All right, one's a little tricky. Keep an eye out for it. Whole number, that would be 1. If you put the number 1, nice job. You got it right. Let me erase my clutter here. Working on this one, whole number. This right here, you guys, the whole number that this 0.755 and so on is closest to is the number 1. Other whole numbers close by would be, well, 0, maybe 2. These are whole numbers, right? Maybe it's close to 3. Maybe it's close to -1. Round to the nearest whole number. Which one is it the closest to? -1, 0, 1, 2, 3. Of all the whole numbers that exist, which one is this the closest to? And the answer is 1. I like to think of money. It's like 75 cents. It's closest to $1. Next one, percentage, 76%. All right, so same thing here. We're actually been given 2 tasks. We're tasked with changing it to a percent, and then it doesn't say it right here, but it does not want any decimals. So it's saying, like, when it just says percent, it doesn't want 76 point anything. It doesn't want 75 point anything. It wants the nearest percent. So 2 tasks at hand. First task, change it into a percent. So 1, 2, now we are in percent form. Second task, round that to the nearest percent. So 75 point. The 5 after the decimal tells us to round that up to 76%. And finally, for the exact value, if you wrote the entire thing out, you got it right. This is the whole thing, okay? Exact value. So heads up, you're either going to be asked to give a rounded answer or not. If you are not asked to give a rounded or an approximate answer, then you have to provide what we call the exact value. And that would be all the decimals that we have available. Sometimes we'd have to put like a number back in fraction form, like 1/3. That's considered the exact value. So rounding versus exact, you'll need to check almost every answer you give in this class. You'll have to check, do they want me to round it or do they want the exact? And don't worry, the directions are very clear. Every single question will clearly state if they want you to provide a rounded answer. If they don't state it, you don't round it. All right, that finishes our discussion on section 1.1. My name is Jami Emigh. Thank you for being here. Our next video will start on section 1.2. Title will be Types of Data. See you soon.